Code review practices interview questions. Okay, let's talk about what a code review really is. It's way more than just someone looking for errors. Think of it as a collaborative learning session where experienced developers help their colleagues write better code. The main goal? We want to catch potential bugs early, share knowledge and best practices, and make sure the code is clear, maintainable, and follows our team's standards. It's also a great way to ensure everyone in the team feels ownership of the product. Okay, let's talk about why code reviews are so important. They're not just a tedious chore, they actually offer a ton of benefits. Primarily, they dramatically improve the quality of your codebase by catching mistakes and ensuring everything makes sense before it goes live. But it's more than that, they also create opportunities for knowledge sharing between developers, especially helpful when your team members are learning the ropes. Regular reviews can prevent accumulating technical debt, which will save you time and effort in the long run. Plus, they help keep everyone on the same page with coding standards and even spot potential security issues. Okay, so let's get down to brass tacks. What should you actually be looking for when you're reviewing someone else's code? It's not just about spotting errors, it's a much bigger picture. First off, always check if the code is doing exactly what it's supposed to do and meets all the requirements. Next, make sure it's readable. Clear variable names, consistent formatting, these things make a huge difference in understanding the logic. Then, don't forget about error handling, or potential problems being addressed properly. Security is crucial too. Look for vulnerabilities that could be exploited. And lastly, think about maintainability. Will this code be easy to modify and update down the line? It's all about making sure we're building robust and dependable software. Okay, let's talk about disagreements during code reviews. They're totally normal. My strategy is all about understanding the other person's point of view first. I always make sure to actively listen and ask questions to really get what's behind their concerns. Then, I validate those concerns by acknowledging them, even if I don't agree immediately. Next, I clearly explain my reasoning using facts and data, avoiding any blame. Finally, I try to find common ground. Can we incorporate some of both ideas? If that doesn't work, it's okay to escalate the issue to a senior engineer for help. Okay, so when it comes to tools for code reviews, I've had a pretty varied experience. GitHub pull requests are absolutely my go-to. They're fantastic for in-context discussions and keeping everything tied directly to the code. Then there's SonarQuery, which is great for automatically flagging potential problems before we even get to reviewing lines of code. I've also used Crucible and Review Board for more structured reviews, especially when those projects needed a lot of formality or traceability. And let's not forget about linters like ESLint. They catch many issues early on, making the review process much smoother. I'm always open to learning new tools too, as long as they help us improve our code quality and collaboration. Okay, so let's talk about the difference between peer reviews and formal code reviews. A peer review is basically when you just chat with another developer about the code. It's super informal, all about making sure everyone understands what's going on and catching any obvious mistakes. It's a great way to build team knowledge. Now, a formal code review goes much further. It's a structured process, often using tools like pull requests, where you have specific guidelines and checklists to follow. Reviewers are assigned based on their expertise, and everything is documented so you can track improvements and ensure high quality across the whole project. Essentially, peer reviews are friendly chats, while formal reviews are more rigorous examinations. Okay, let's talk about giving constructive feedback during code reviews. The key isn't just pointing out problems, it's about fostering a collaborative environment where everyone learns and improves. First, focus on explaining why something needs changing, not just stating what's wrong. Instead of saying that variable is misspelled, try framing it as an opportunity to improve consistency. Then start with the positives. A little appreciation can go a long way in making someone receptive to feedback. Be specific, tell them exactly what you're seeing and suggest how it could be better. And most importantly, ask questions to understand their reasoning before offering solutions. Frame your suggestions as could we or have you considered, rather than directives. It's all about building a supportive atmosphere where everyone feels empowered to learn and write great code together. Okay, so let's talk about how we balance making sure our code is really solid with actually getting it reviewed in a reasonable amount of time. It's a common challenge. First, you need to prioritize. Think about what really matters: security, potential bugs, and if the code follows our team style guidelines. Having clear guidelines for everyone makes the review process much smoother. Then, instead of just saying something is wrong, frame your feedback with specific questions. And don't be afraid to set a time limit, maybe 30 or 60 minutes, so you can stay focused. Finally, use tools like linters and formatters to catch some of the simpler issues automatically. Okay, let's talk about coding standards. When I'm reviewing code, my main goal isn't just to find errors, it's to make sure the code base is consistent and easy to understand for everyone on the team. I usually follow a combination of things like the official style guides for the language we're using, which helps with formatting. Then there might be project-specific guidelines that our team has put together, covering how we name variables or handle errors. I also look for adherence to design principles like SOLID and DIY, which are super important for making code maintainable over time. And of course, I always prioritize readability. Clean code is easier to work with. Okay, let's talk about how we tackle those massive pull requests that can feel like a mountain. First, I'll take a quick look at the whole thing: what's being changed, why it's changing, and what issue it relates to. Then, I don't try to swallow the whole thing. Instead, I break it down into smaller, logical pieces. Think of it like eating an elephant one bite at a time. I focus on one particular aspect, like functionality or security, for each chunk. It's super important to have a checklist of what needs to be checked: clarity, performance, security, and code style. And most importantly, I communicate with the author. Asking questions helps make sure we're both on the same page. Finally, giving feedback in small, targeted comments makes it easier for them to understand and fix things quickly. Okay, let's talk about how we prepare our code before getting it reviewed. It's really important to show you've put in the effort up front. First off, I always do a quick self-review, like a second pass over my own work. Then, I make sure all the tests are passing on my machine. Next, I'll run a linter and formatter to catch any style issues or formatting problems. I also tend to break down bigger tasks into smaller, more manageable pieces, and write clear commit messages explaining why those changes were made. Basically, it's about demonstrating that you've taken care of the basics so your reviewers can focus on the higher-level design and logic. Okay, let's talk about a really common scenario in code reviews. You find code that works perfectly well, but doesn't quite follow our team's best practices. The first thing I do is try to understand the developer wrote it that way. There might be a good reason behind it. Then I explain my concerns clearly and specifically, focusing on how it could impact things like maintainability or future bug fixes. It's really important to offer a concrete alternative solution, not just point out what's wrong. Finally, code review is about collaboration. Let's work together to find the best approach, document our decisions, and keep everyone learning. Okay, let's talk about how to tackle that mountain of feedback you might get during code reviews. The key is not just accepting everything is important. It's figuring out what really matters most. Start by thinking about the potential impact. Are we talking about a serious bug or a minor styling change? If several people point out the same thing, it's probably worth investigating further. Also, consider how one change might affect other parts of the code and whether it impacts your area of expertise. Don't be afraid to ask questions and have a quick discussion with the author that can often shed light on what's truly important. It's all about balancing immediate fixes, long-term quality, and teamwork. Okay, let's talk about how automated code analysis tools fit into the code review process. These aren't meant to replace human reviewers, far from it. Instead, they are incredibly valuable assistants. They can quickly scan your code for things like style inconsistencies, potential bugs, and even security vulnerabilities before you or another reviewer gets a chance to look at them. By handling these simpler issues automatically, they significantly reduce the time you spend on review itself, allowing you to focus on bigger picture concerns like design and logic. Okay, let's dive into why security reviews are so important during code checks. It's not just asterisk about catching silly mistakes, it's a key part of protecting our applications. Code reviews act as a strong defense against vulnerabilities. Think of them like an extra layer of protection for your software. By regularly looking for potential weaknesses, we can significantly reduce the risk of things like data breaches and system compromises. Plus, many regulations actually require us to follow secure coding practices. And let's be honest, protecting our company's reputation is always a good thing. We should pay close attention to common issues like SQL injection, XSS attacks, or problems with how users are authenticated and authorized. It's an investment that pays off in the long run. Okay, let's dive into how we can make sure the code we review is running smoothly. First, you need to really understand why the code exists and what performance goals were set for it. If possible, check if any profiling tools are available. They're fantastic for pinpointing exactly where time is being spent. Then, we look for common areas that can cause performance issues, things like inefficient algorithms, poorly optimized database queries, excessive I/O operations, and even just loops that aren't working as efficiently as they could be. Don't forget that optimization shouldn't come at the expense of readability. A clean codebase is much easier to improve in the long run. Okay, let's talk about how you handle feedback during code reviews. It's super important that you don't just get comments and then forget about them. The key is a really good tracking system. Think of tools like Jira or GitHub Issues. They help you create a dedicated ticket for every piece of feedback, so it doesn't get lost in the shuffle. Also, labeling things clearly, whether it's a style issue, a bug, or something else, and prioritizing based on how important it is, like a critical bug versus just a suggestion, keeps everything organized. Assigning each ticket to a developer and setting reasonable deadlines ensures that things actually get done. And when you resolve the feedback, make sure your response explains why you made the change. Don't just say fixed, show the reasoning. Finally, closing out those tickets when they're complete is crucial for documenting the entire process. Okay, let's talk about getting junior developers up to speed with code review. It's absolutely vital. It's not just about catching bugs, it's a fantastic way for them to learn and grow as programmers. The most important thing is to clearly explain why code reviews are so valuable. Then, start gently. Don't throw them straight into reviewing massive projects. Focus on the bigger picture first, things like structure and readability. Pair programming in the beginning can be a huge help. Having an experienced developer walk them through it beforehand really sets them up for success. And when they get to review solo, encourage small, manageable changes. Always remember to focus on the behavior of the code, not just nitpicking about style at first. Tools like Rubber Duck debugging can also be incredibly helpful. Getting a junior to explain their code out loud is often the best way to identify issues. Finally, start with a simple checklist, things they should look for during reviews. It will make the process less overwhelming. Okay, let's talk about documenting decisions during code reviews. It's seriously important. Think of it like building a roadmap for your codebase. Why do we document? Well, it helps everyone understand the why behind changes, which is super valuable when revisiting older code or onboarding new team members. There are a few ways to do this. You can add short comments directly in the code itself when needed. Use your code review tools. Built-in commenting features, highlighting specific lines and adding notes is really helpful there. And for bigger decisions like architectural changes, it's best to create dedicated issue entries or documents. And most importantly, always explain why a change was made, what other options were considered, any trade-offs involved, and how it might affect dependent parts of the system. Okay, let's talk about checklists. They are a really important tool in code reviews because they help keep things consistent and thorough. Think of them as a to-do list specifically for reviews, making sure you don't miss any key areas. Using a checklist helps reduce biases, so you're looking at the code objectively based on predefined criteria. It also ensures you cover all the important aspects like security, performance, and readability. A good checklist will include things like ensuring there are enough tests written for the code and that error handling is done correctly. And don't forget, checklists should be customized to fit your project's specific guidelines. Okay, let's tackle technical debt. It's a really common scenario during code reviews. The key is to move beyond simply saying this isn't ideal. Instead, we want to understand why the developer made that choice and then guide them toward better solutions. I usually break my approach down into 3 steps. First, I identify the specific debt and explain exactly why it's a concern, what are the potential downsides. Then, it's crucial to have an open discussion with the developer, focusing on their reasoning and exploring alternative approaches. Finally, I offer concrete suggestions showing them how they could refactor or simplify the code while highlighting the benefits of doing so. Think of it as helping them make a strategic trade-off. Sometimes quick fixes are okay, but we need to be mindful of the long-term consequences. Okay, let's talk about the rubber duck method. It's a really clever little debugging trick. Basically, you take your code and explain it out loud to an inanimate object like a rubber duck. The idea is that when you have to explain something step by step, you quickly realize where you might be making mistakes or assuming things that aren't true. It's super useful when you're wrestling with a complex bug, trying to make sure your code is easy to understand, or just want to catch any potential errors before they cause problems. Think of it as a quick way to check if you actually know how your code works. Okay, let's talk about how we handle code reviews when our team isn't all in the same room. It can be tricky, but it's totally manageable if we have a solid plan. First and foremost, we need crystal clear guidelines. What are we looking for in a good review? Style, functionality, security. Let's document it. Then, tools are absolutely essential. Platforms like GitHub or GitLab really make this process flow smoothly with pull requests and merge requests. But the biggest thing is communication. A reviewer should understand why the changes were made. Video calls and even well-structured asynchronous discussions can help a lot. Also, keep those reviews manageable. Breaking down big tasks into smaller PR makes everything less daunting for everyone involved. And finally, rotating reviewers keep things fresh and prevent any one person from getting stuck in a rut. Okay, let's talk about building a really good code review process, one that's actually enjoyable for everyone. It's not just about finding bugs, it's about fostering a collaborative environment where people feel comfortable sharing their work and learning from each other. I always lead by example, making sure my own code is open to feedback and admitting when I don't know something. Then, instead of focusing on strict rules, I emphasize core principles like being open to suggestions and assuming good intentions. It's super important to give specific, actionable feedback, not just saying this could be better, but explaining how it could be improved. Starting with what's already good about the code helps too. And finally, creating a safe space for questions and discussion is key. Code review should feel like conversations, not interrogations. Okay, so when you're faced with code in a language or framework you're not super familiar with, it's all about approaching it strategically. First, always get the context to understand why the code was written and what it's supposed to do. Then start with a top-down approach, getting an overview of the architecture. Next, focus on those key, potentially tricky sections. And finally, don't hesitate to ask for help. Collaboration is really important here. It's less about finding every single tiny issue and more about understanding how it all fits together and its potential impact. Okay, let's talk about making sure we have enough testing during code reviews. It's not just about finding bugs, it's about verifying that everything works as expected in different situations. First, make a habit of reading the tests alongside the actual code. Really understand how they're checking the logic. Pay special attention to edge cases and boundary conditions. These are often where problems hide. Think about what could go wrong: invalid inputs, data failures, etc. Also, consider the variety of test types. Unit, integration, and end-to-end tests all play a role. And finally, always ask what-if questions to uncover potential issues. A comprehensive test suite shows you've built confidence into your code and it's much less likely to break something new later on. Okay, so when it comes to reviewing changes that are purely focused on improving code quality refactor without altering its functionality, I like to start by really understanding why the changes needed. What's driving the refactoring? Then, I shift my focus to how the code is structured and whether it's easy to read and understand. I always lean heavily into unit testing because that guarantees the underlying behavior hasn't changed. I also look for any unexpected side effects, basically making sure this improvement doesn't unintentionally break something else. Finally, it's about improving readability and making the code easier to maintain in the long run. It's a process of small steps, lots of testing, and a watchful eye. Okay, let's talk about when you need to say no during a code review. It's totally normal. You won't always be thrilled with every submission. The most important things are serious bugs that could break the application. Definitely reject those. Then there are security vulnerabilities. You don't want to introduce risks. Also, if the code goes completely against established architectural plans or design patterns, a rejection gives you a chance to discuss and fix it. Lack of testing is another big one. Make sure there's enough to cover the changes. And finally, consistently bad style can be a problem too, but always provide feedback alongside your rejections so everyone learns. Okay, let's talk about code smells. They're not bugs, they're like little warning signs in your code that tell you something might be a bit off. Think of them as hints suggesting potential design or maintainability issues. We've got things like overly long functions, duplicate code, big classes packed with too many responsibilities, and lengthy parameter lists. Also, watch out for magic numbers. Those are just literal values thrown into the code without explanation. When you're doing a code review, pay attention to whether the code is easy to read and understand. Is it difficult to make changes? Does it feel overly complicated? And most importantly, ask yourself if there's a simpler or more reusable way to do things. A good code smell investigation can really save you time and headaches down the road. Okay, let's talk about making sure your code aligns with regulations and industry standards. It's more than just finding bugs, it's about building trust and staying on the right side of the rules. First off, you absolutely must understand what those regulations or standards are that apply to your project. Don't guess. Then create checklists and templates specifically for these requirements. These should cover everything from data privacy to security vulnerabilities. Tools like Sonar Codec can help automate a lot of this process, catching potential problems before they become serious issues. Also, think about risk. Where are the biggest potential compliance gaps? And crucially, document why you're making changes and how they relate back to those standards. Okay, so let's dive into some common mistakes developers make during code reviews. It's really easy to get caught up in the details, like fixing a tiny typo or suggesting a slightly different formatting style. But what often happens is reviewers don't take the time to actually understand what the developer was trying to achieve with the code. It's super important to focus on the intent behind the changes. Then, there's the tone. Delivering feedback in a way that feels critical or judgmental can really shut down communication and make developers less likely to accept your suggestions. Also, don't forget context. A suggestion might look great in isolation, but could be problematic if it doesn't fit with the overall architecture of the project. And finally, try not to get bogged down on small details too early. Bigger issues often need more attention. The best code reviews are collaborative and focused on helping each other write better code. Okay, let's talk about keeping our code looking and feeling consistent. It's super important for readability and collaboration. The first step is to clearly define your team's coding style. Think naming conventions, how much space you leave around brackets, what kind of comments you use, basically everything that makes the code look uniform. Then, let's make sure everyone actually uses those guidelines. Using tools like ESLint and Prettier can automatically enforce the rules, which takes a huge load off reviewers. It's also helpful to have regular discussions about best practices so everybody's on the same page, and for senior developers to consistently lead by example. Okay, let's talk about pair programming versus traditional code reviews. Both are designed to help us write better code, but they're fundamentally different. Pair programming is like having two people building something together in real time. One writes the code and the other watches, offers suggestions, and keeps the whole thing on track. It's super collaborative. Traditional code reviews involve submitting your code for others to look over after it's written, usually through tools like pull requests. It's more of a checking the work process. Understanding these differences is key when discussing software development practices in an interview. Okay, let's talk about how I approach reviewing configuration files and deployment scripts. First, I take a quick look at the changes themselves, what's actually being modified and why. Next, it's a rapid syntax check to make sure everything is properly formatted. Then, I really dig into the logic, thinking about potential dependencies, side effects, and any security risks. Crucially, I always review these changes in context, looking at related files and how they fit together. And finally, I advocate for tests, either automated or manual, to ensure everything works as expected before we push anything live. Okay, so let's talk about how we handle code reviews when things are really urgent, like a critical hotfix. The first thing is to quickly figure out how important this fix actually is. It's not always the biggest deal. Don't skip the review entirely though. Even for these situations, a quick check is essential to avoid new problems creeping in. We need to focus on the code that directly solves the immediate issue and leave the style fixes and more complex refactoring for later. It's really important to communicate clearly with the developer who made the change, quickly explaining any concerns you have. And finally, let's aim for a super fast feedback loop. Getting those critical issues resolved within just an hour or two is ideal. Let's tackle how to approach code reviews when you're working with experimental or prototype code, a super common situation in fast-moving projects. The key shift here is that we're less concerned about perfect production-ready code and more focused on validating the core functionality and making sure the overall direction makes sense. Think of it as, does this achieve what we set out to do, instead of is this perfectly formatted? We want to prioritize high-level checks like verifying the logic works, evaluating the architecture for scalability, understanding any underlying assumptions, and ensuring you can actually add tests later. Smaller, more frequent reviews are much easier than trying to catch everything in one big session. And honestly, it's totally fine if the prototype isn't pretty. Just document any limitations clearly. Okay, let's talk about how code reviewers and authors differ. As the author, you're the one actually writing the code, making sure it works and is easy to understand. You need to follow the team's coding standards and build a solid solution that meets the requirements. Now, the reviewer is there to take a step back and look at what's been written. The job is to spot any potential problems like bugs or security vulnerabilities, make sure the code is readable for other developers, and give feedback on how it could be improved, all without necessarily telling the author exactly what to change. Okay, so let's tackle how we can make code reviews even better in an existing team. First off, it's crucial to really understand the process is currently working, what steps are involved, who's doing what, and where things tend to slow down. Then, we need to identify the biggest challenges. Maybe there aren't clear guidelines, or reviews feel too long and don't get to the point. Don't try to overhaul everything at once. Instead, introduce small improvements like checklists for consistency. Think about readability, testing, and security. Focus on giving constructive feedback that explains why changes are needed, not just stating what needs to be fixed. And lastly, keep an eye on how things are going by tracking metrics and continuously iterating based on the team's experience. Okay, let's talk about merge conflicts. They're a really common thing when multiple developers are working on the same project. Basically, it happens when two or more people change the exact same lines of code at the same time, and Git can't automatically figure out how to combine those changes smoothly. It's like trying to edit a document with someone else without talking. You end up with conflicting edits. During your code reviews, you'll often see these conflicts flagged in your tool. The key is to really understand why the conflict happened, talk to the developers who made the changes, and then figure out the best way to merge those changes together, or sometimes even rewrite the code if needed. Always document how you resolved the conflict. It's helpful for everyone down the line. Okay, so let's talk about a really common situation in software development when you're facing tight deadlines and have to do code reviews. It can be tempting to just rush through things to get them done on time. But that's where it gets tricky. The most important thing is to be upfront, tell your team lead or manager right away about the pressure you're under. Then prioritize what truly matters. Really focus on catching major bugs and security issues. Don't waste time polishing minor style points when something serious might be lurking. See if there are ways to break down the work into smaller parts for separate reviews, or maybe push some less critical tasks to a later sprint. And always document your decisions, especially if you're making compromises due to the tight timeline. It's about finding a balance between meeting deadlines and delivering solid code. A quick initial scan combined with a deeper dive later is often better than nothing at all. Okay, so let's think about how we can tell if our code reviews are actually working. It's not enough to just spot bugs. We want to make sure they are improving the overall quality of our code and helping us build better software. We can break down metrics into a few key categories. First, let's look at code quality, things like how many bugs we find during the review process compared to later on, and also measuring complexity. Then we need to think about how efficient the reviews themselves are, things like how long they take and whether our reviewers are overloaded. But it's not all numbers. We should also be paying attention to factors like the quality of the feedback being given, developer satisfaction, and whether the process is actually helping people learn and share knowledge within the team. Okay, let's talk about making sure your code base has helpful comments. It's not just about saying this does something. We want to focus on why things are done a certain way and highlighting potential tricky spots. Think of functional comments explaining what the code is trying to achieve, intent comments that explain the reasoning behind design choices like why you chose a loop over recursion if performance is important, and then edge case handling to document any special considerations or error prevention. Avoid commenting on how the code works. It should be self-documenting. And definitely ditch redundant comments that just state the obvious. Okay, so when it comes to reviewing code, especially with tests, I don't just look at the green check marks. It's crucial to really understand what each test is trying to achieve. What business requirement are we confirming? I always start by running the tests themselves in a continuous integration environment. That way, I can see exactly where things go wrong and quickly locate the problem area. Then I dig into the code itself, making sure that it aligns with the test's intention. I'm particularly attentive to edge cases, those unusual inputs or scenarios that could expose weaknesses. Finally, I think about whether the tests are truly covering all of the important pathways through the application, rather than just focusing on lines of code. Let's talk about what happens when you miss something important during a code review. It's totally normal. The first thing to do is acknowledge it right away, making sure it's clearly flagged. Then chat with the developer who wrote the code and understand why you didn't catch it. Was it confusing code or just a momentary lapse? Collaborate on fixing the issue together, and most importantly, document what happened so you can learn from it and avoid repeating the same mistake in the future. Okay, so when we're looking at how to get code reviews done faster and with less back and forth, there are a few really powerful techniques. First, make sure you have clear guidelines. A checklist of what reviewers should be looking for helps everyone stay on the same page. Then keep those pull requests small and focused. Large changes can be overwhelming to review. Automated tools like linters and formatters also help catch issues early. And sometimes, working in pairs on complex tasks can dramatically reduce misunderstandings. Finally, a little communication before diving into review. Just explaining the why behind your code can make a huge difference. Okay, so tackling review fatigue in big projects, it's a really common challenge. The first thing we do is focus our efforts. Instead of trying to meticulously examine every line of code, we prioritize key areas like security and performance. We use checklists and tools to highlight what truly matters. Next up, time-boxing the reviews. Setting a clear time frame keeps things moving and prevents getting stuck in endless loops. Rotating reviews ensures everyone has a chance to contribute and brings fresh eyes to the process. And crucially, we aim for frequent, smaller reviews rather than massive, infrequent ones. Consistency is key to avoiding burnout and maintaining high-quality code. Okay, let's dive into how we make sure code is truly readable during our reviews. It's not enough for something to just work. It needs to be a joy to understand and tweak later on. First, instead of jumping straight to fixing typos, let's ask why. Why was the code written this way? Then, we should focus on making sure the code is easy to read with clear names, consistent formatting, and helpful comments where necessary. Breaking down large chunks of code into smaller functions is also really important, so each part does one specific thing well. Don't forget to think about edge cases. How does the code handle unexpected situations? And finally, always be on the lookout for duplicated logic. Refactor it out whenever possible. It's all about building a shared understanding and keeping our codebase healthy. Thank you for watching.